clipper circuits. Here we find that at the topmost portion we can differentiate the clippers in the two ways. One is the positive and the one is the negative. So because the diode is attached lonely, so this is simple series clipper. While if the battery is attached, then biased series clipper. Because these three circuits clip out the positive portion, so this is positive clipper. Similarly, here the diode is attached in the other direction and it clips the negative portion of the waveform, so this is negative clipper. Here the battery is attached, so these are the biased negative clippers. The operation which is discussed in the previous slides are the same. I can again brief it out. Here the diode is attached, which is reverse biasing condition for the positive half. So no current is there and no drop is there. From 0 to pi no waveform is there. While for pi to 2 pi, the diode, here the polarity is changed, negative here, positive here, the diode is in forward bias condition. It can conduct and a finite drop across the load R, and there must be a certain V0 which is equal to the input waveform. This one is coming here, and here we find that battery is supporting. If battery is supporting, that means the amplitude will raise with Vm plus V. Here the battery is opposing, that means amplitude is decreases, Vm of minus of V. So Vm minus V. Another thing is shown here is that if the battery supports the system, then it can goes in the direction of the amplitude. That means battery supports, so battery V is shown always in the direction where the waveforms come out. While if the battery oppose the conduction or oppose the diode, that means this V voltage come just to the opposite direction of the baseline. Similarly, for the negative clipper, for the positive half cycle, the diode conducts and there must be a drop equal to the input waveform from 0 to pi, which is here. Here the battery oppose the system, so Vm of minus V is the first concept, and for the positive half cycle the loop conducts, there is a drop which is equal to Vm minus V. While for the negative half cycle the diode acts as an open switch and there is no current, so no waveform from pi to 2 pi. While here we find that the battery supports the system, that means Vm plus V. Now as per the polarity at the input terminal, the diode is in forward bias. So for the positive half cycle the current conducts and a drop across R, and the output waveform is somewhat Vm plus V. While for the negative half cycle there must be a open switch, so no current is there, no drop is here, and finally pi to 2 pi no waveform is appear. Similarly, if battery oppose the system, that means it comes just opposite to the baseline, and when battery supports the system, then it comes along with the waveform. So this is the brief summary for the series clippers, which are normal as well as biased in nature. Now, one of the major portion of the clippers is the parallel clippers. What happens if we attach the diode in the parallel direction? Now, because we consider the diode is ideal in nature, so there must be a certain change in the concept for the appearing of the waveform across the terminal. What is this? I can explain. This is the basic circuit for the clipper, and we find that R is attached here and diode is attached parallelly. So these clippers are named as parallel clippers. Here we find that this is the positive terminal, this is the negative terminal. So for the positive half cycle from 0 to pi, or for the half cycle, the waveform is positive and the polarity is this, and there must, and the diode is in forward bias condition. For the diode in forward bias condition, the current conducts. As we know, the diode is ideal, and if the diode is ideal, that means resistance across diode is 0, and if the resistance is 0, that means drop is 0, and when drop is 0, that means V0 is 0. So this is the difference. If the load resistance or R is connect across the output, then there must be a certain finite load. But if we replace this R with a diode, then we find that R is 0, drop is 0, waveform is 0. So even if the diode conducts, then there is a no drop, and if there is a no drop, that means the output waveform is 0. So for this input terminal from 0 to pi, the waveform is not appearing. Now for the negative half cycle from pi to 2 pi, the terminals are changed. Now the diode acts as an open switch. Means that if diode is here, okay. If diode is not here, then it is also okay, because it is now open switch. So if we apply Vi across these terminal, then this similarly appears across directly at the output terminal, because we just forward a waveform from this terminal to this terminal, because this is open circuit, so nothing is connected. That means the similar waveform is appears for pi to 2 pi for the negative half phase. So this is the difference. If diode is connected here, there must be a drop. But if the diode is here, because diode is ideal, drop is 0, that means the V0 is 0. Similarly, we can also replace this waveform by sinusoidal waveform or triangular waveform in this way. The concepts are the same, but only is the difference in the working of the diode, or where we have to connect the output, across the resistance or across the diode. So here we collect the output across the diode, not across the R. So this is the basic difference between series and parallel clipper. These are the two different circuits for the clippers. First one is called parallel clipper. Here, because positive portion is clipped off, that means this is positive clipper. While here negative portion is clipped off, that is negative clipper. Here again we can discuss, for positive half cycle the diode conducts, and the diode conducts because resistance across ideal diode is 0, that means the drop is 0. Drop is 0, V0 doesn't appear, so no waveform for positive half cycle. While for negative half cycle, the polarities are changed and the diode reverse bias, and for reverse bias it acts as a open switch, and when it acts as a open switch, whatever is applied across the input is directly appears across the output, and the waveform is this. Similarly, for the second circuit, for positive half cycle, there is a diode which is reverse bias in nature, and if this is reverse bias in nature, then it acts as a open switch. If this is a open switch, that means Vi is directly appears across V0. So this is the waveform for the positive half. While for the negative half direction from pi to 2 pi, the polarity is changed. Negative here, positive here, diode is forward bias and a current conducts. Still, because resistance is 0, drop is 0 and nothing is applied across V0. So pi to 2 pi, nothing is applied. These are the